Okay, I'm Len Bass. I'm going to talk about Docker. So the genesis of this is that last year at SATURN there was a workshop on containers. I got the impression at the time that there were a fair number of people who would like to know more about containers just at an elementary level. There were also a fair number of people that knew more than I did. And so that was one of the motivations, was just give an introductory part of, I'm okay? Yeah. Just give an introductory introduction to Docker. And then the second is that I'm teaching a course in DevOps at the MSc program at Carnegie Mellon, and this is a lecture. So this is a lecture that I give to the students. This is the assignment I give to the students. So there wasn't any work involved in preparing this, and that was important to me. So my expectations are that you've installed Docker on your laptop. So we'll see how well you follow. How many of you have installed Docker on your laptop? Most of you not. Okay, so I would suggest you go ahead and do that. Otherwise, there's not if you don't have a laptop, then sit next to somebody that does. But there's not going to be a lot of hands-on if you don't have something to put your hands on, And so my intention was that people had installed Docker. There are a wide variety of operating systems and so on that it runs on, and so again, the assumption was that you've installed it and you've dealt with the installation problems and you can run the hello world kind of thing, or vicariously. Okay, so the network, the SATURN network is SATURN 2017 something, and the password is Hilton 428, all lowercase. So that's what it's going to be. So if you look at this picture graphically, what you think is this is going to be a Goldilocks picture, right? There's the mama bear and the papa bear, and that's true. I should have done this one at a time. But in general, if you look at processes have address space isolation, but they don't have network isolation. They don't have file isolation, but they are lightweight. Okay, so processes are good from some aspects. If you look at virtual machines have all the isolation you want, but they're heavyweight. Okay, and that's where containers, in particular Docker, come in. So it gives you address space isolation, it gives you file isolation, it gives you network isolation, and it's pretty lightweight. Okay, and so part of what I'm going to talk about today are the techniques I use to make it lightweight. So containers are a fairly old idea. I think they date from the 70s. Everything dates from the 70s, it turns out. But Docker is a recent updating of a Unix service, and they did a good job. So Docker is pretty good. So this is one of the pictures that the Docker people generated. If you look at the virtual machine world, everything is isolated in a silo. So your silos include your operating system, any libraries you use, and your application. Docker has sharing. So forget the Docker engine, but it shares the host operating system. And it could conceivably share libraries. And then you have individual apps. And there's more to it than that in terms of there are layers, and we'll talk about what that comes from. But if you just think about deploying one of these things, you're going to be deploying a lot more than if you deploy this. Not for the first instance, but for subsequent deployments. Okay, so what the picture, so somebody was talking about the documentation book. We would not like this picture, but this is the Docker picture. So there are two computers kicking around that are of interest. There's the Docker host and the client. Client's where you give Docker commands. In this case, these are command line commands. And the host is where everything happens. So as with virtual machines, you have a virtual machine image and an executing virtual machine, and the two things are different. The image is just a collection of bits. The executing virtual machine is actually, I don't know what you want to call it, a computer doing its thing. Same thing with Docker. You have images, and a container is a running image. So when you hear Docker containers, it's a little bit ambiguous because people tend to think more of the image than they do of the running thing. But that's the terminology. So a image is constructed in terms of layers. And this is essentially the key mechanism that Docker uses to become lightweight. So you have an image, and in the exercise you'll start with Ubuntu image, and then you put more software onto it. So you build up the thing. At any point in this process of adding software to the image, you can commit it. You can say, I want to create a new image with a new name, and you now have a new addressable image. Okay, so you can reference the pieces or the whole thing. And when you're deploying or doing other kinds of transfers, which I'll talk about what I mean by that, it's the image. It's not the container. So far, so good? Okay, so yeah, question, sorry.
Yeah, one question. So the image contains information about the operating system, or it's totally isolated? You just upload the image?
The image contains information about the operating system. Okay. Now, it assumes a particular operating system that it's running on, so it won't run on any operating system, but it contains certain information. So the first step in the exercise is to get me something that runs Ubuntu. But that's going to get all washed out when we do the sharing. You'll see this in a minute. Okay, so let's just look at some timing numbers. So first of all, capital G is either gigabyte or gigabit, depending on the context. And as we heard in the keynote, giga is a word that means something to people these days, but if you get any smaller, it doesn't. And so if you think about transferring things, a 1 gigabit network is actually around 35 megabits in practice, just because of network interference and network protocols and so on. So if you're going to load an operating system, which is roughly a gigabit, it's going to take you 30 seconds. Actually, it's going to take you more because there's more stuff, but you know. And so just saying that I'm sharing an operating system is going to save you 30 seconds in deployment. Okay, and again, in practice, it's going to be more. Okay, so the key thing about the layers is when I'm deploying something, I don't deploy when I'm redeploying something, I'm sorry, say it correctly, I don't redeploy the whole thing, I just redeploy the layers that have changed. So that's my comment about the operating system. You load the operating system once, now I want to update it, I don't have to load it again because it's not going to change. I just load the part that's changed. And so the construction of the layers turns out to be important in how you do that. If I have a library that is not going to change much, I would make that a separate library and a separate layer, and then the application on top of that would be updated, but not that layer. Okay, so you sort of synchronize the layers that you build with the dynamism, is there such a word, of the software, how much it changes. Okay, so a virtual machine gives you total control. Put any operating system you want. You can control within the hypervisor. You can control how you do file allocation. You can control how you do networks. You control what protocols you use. Everything you want. Containers constrained. Okay, So right now, well, when I wrote this slide, just worked on Linux. I don't know what soon means, but it may be that you can get Windows and Mac. You certainly can get Windows and Mac native versions at this point. And you have limited networking options and limited file sharing. So it is, in fact, going to be a lightweight virtual machine. It looks like a virtual machine, but it doesn't have as much stuff in it, and it doesn't give you as much power. Okay, so now let's assume that you've done the assignment. Okay, and so we will have the grader walk around and grade everybody to make sure they've got the assignment done. You've loaded Docker. You have Docker, and you've run Hello World. You need to be able to port forward 8080. So if you're using VirtualBox as a host, and you can see that it shows up, VirtualBox is in charge of port forwarding. So one of the things I learned in teaching it, so I teach a DevOps course in the Masters of Software Engineering. One of the things I've learned, DevOps is in some sense an application-oriented topic. It's not a foundational topic. And what I've learned is that these students, who all have undergraduate degrees in computer science, have a lot of gaps. One of the gaps they have is in terms of networks. They don't know what ports are. They don't know how DNS servers work. So there are a lot of practices in DevOps which say, you know, let me change how messages are routing by changing the DNS. Okay, and you can do that if you know what you're doing. And if you don't, and you know how it works. If you don't know how it works, that's just magic. Okay, so this whole notion of port forwarding, in the class I have a lecture where I talk about ports. I have a picture of a hotel switchboard. You know, this is where it comes from. I talk about DNS servers and the hierarchy. I talk about IP addresses, all of which I would have thought they knew, but they don't. So such is life. Okay, so we're all set up now. What you see should be a machine. If you do a ls, it should give you a directory structure. If you now say pull Ubuntu, Docker pull Ubuntu, then you're loading a container that understands Ubuntu. Small u, yes. Oops, that's a word, yeah. Word is always capitalizing Ubuntu when I type it. PowerPoint, yeah. It's all these systems have things to help you, which are probably, 60% helpful? I don't know. But it's lowercase, yeah. Okay. People have their image, the ones that have computers?
It does run these on Macs, like AWS macOS.
Okay. So you have VirtualBox, you don't have VirtualBox? No. Native, okay. So you don't need to worry about port forwarding then. Yeah, I tried to do the native Windows thing, and I don't think my computer was powerful enough because it kept complaining about the amount of memory that it took and the amount of memory that was left. And so one of the things I discovered in teaching this course has nine assignments, all using open source software except for one which uses AWS. The open source software people are not very good about backward compatibility. So I got the assignments, or I wrote down a set of, or I made up the assignments. I did the assignments. I wrote down a set of instructions last year. This year I just thought, well, maybe I should just test this. Nothing worked. Okay, I went from Ubuntu 12 to Ubuntu 16. They no longer package Java 7. They package Java 8, which means that all the file names are different in the Java exercise they have. So dealing with open source is a mixed blessing in terms of keeping up to date. Okay, so you've loaded Ubuntu, and now if you type Docker images, you should see two things. Okay, you should see Hello World as an image because you ran the Hello World thing, and you should see Ubuntu. So Docker images is a command that gives you a list of the images in Docker. And again, the images are these partially loaded pieces of software. Yeah.
So before you talked about the host and the client.
This is on the client.
Right, so this is now all on the client, right?
Right. You actually don't see the host.
Okay, well, we'll get to that.
Yeah. Same question.
No, I just go back to the slide where you talked about.
Oh, so I didn't. Okay, so if you type Docker hello world, it should just say hello world. I mean, it gives you a bunch of information. And it might be Docker pull hello world, I'm not sure. I don't remember. Okay. We okay or? Aha. That's a good noise. Okay, we have an aha. Okay, now if you type Docker run -i-t ubuntu, lowercase I, lowercase t, and these are just parameters to Docker. You don't particularly need, you can look them up. You don't particularly need to worry about what they are. What that will do is put you inside the container. Now you're running the container. Okay, so now, yeah.
That runs still local, it still runs here, doesn't it?
Well, I don't know where else it would be besides on.
The container runs on the machine, so back to the host and client. I'm trying to understand.
Oh, you're trying to understand the host and the client.
The one I loaded the images from,
Right.
but I still run them through Docker client on my machine right now here.
Well, so now, if you do an LS, you'll see something different than it.
It comes from the container, but it runs here. It doesn't run anywhere else. It runs on my machine.
Yeah, no, that's certainly true. I mean, yeah, we're not going over any networks.
No, it's the same from nothing.
Yeah, so if it, yeah, but if you had VirtualBox, it could be running inside of VirtualBox, still on your machine. Yeah, it's on your machine. You're now inside, and you get a directory structure that's been loaded for you if you do an LS. So another thing that you need to know if you're going to be a DevOps person is Unix. Yeah, you know, for some of us that's a throwback. You know, I used to know Unix. And now you want to put some software on this machine. Okay, so you're putting software into the container. So apt-get update just says make sure I have the current package, the current list of valid pack. All this generates a lot of output that I'm not showing you. Make sure I have the current list of packages. Then you want to install a particular one called wget, another one called Node.js, because you're going to run a JavaScript program. And then another one, so npm is the Ubuntu package manager. I'm sorry?
It's a Node.js package.
Okay. Oh, so, okay, yeah, that's not a question, that's an assertion. Okay. Yeah, so package managers is another topic that I don't want to get into. Yeah. Okay. So when you get done doing all this, and it should take you a couple minutes, do we have an aha? Or?
No, it's still
When you get done doing this, you will have loaded a bunch of software into the container. The aha moment. So it's pretty fast, actually.
So this is all installing these packages on the Linux and it's on the Ubuntu installs.
On the Ubuntu into the Ubuntu container, as opposed to the image. We're about to get to the image, but we haven't gotten there yet. Okay, can I move on or no? It's still. So you need a faster network than he has. Yeah.
So when you're running a container, are you effectively partitioning the underlying hard drive? Like how much space is allocated to the sensor?
So that's a hard question. So it's actually dynamic. So you can specify if you want. So right now you're at the mercy of the underlying Docker engine as to how much it gives you. But there are parameters you can set to to specify that.
So if we had multiple containers going right now, then if somebody was like a heavy user, they would sort of encroach.
Well, in the native Docker that runs on Mac right now, it gives you similar to the virtual box. You can say, hey, constrain my Docker to 4 cores of this much memory. That's it. That's all it's going to give the containers.
Yeah, yeah. So, you know, I mean, that's a good question. It's just a little more sophisticated than I wanted to get into right now. Everybody have an aha moment? Okay. Yeah, I don't. People have downloaded? Okay. Okay, so let me know when we can do a Control D. What Control D will do for you is exit the container and put you back into the client.
Okay.
I have no idea how long this whole process is going to take. You know, I said an hour and a half, but I don't know. It may be an hour, or maybe 10 minutes. It may be, no, it's more than 10 minutes already. Maybe 2 hours. You know, can't be 2 hours, right? One of my hard and fast rules is you don't go into breaks and you don't go over lunch. Okay, so let's just move on, and when you can catch up. So now you do a Control D, and that puts you back in the client. So now, if you do Docker ps-a, that gets you a list of containers that you have run. It's a little bit confusing because you're in the client. And the container doesn't exist really because you exited it. It could be it's still running. That I don't know. Yeah. And so you get something that looks like this. And what you see are that you have 2 IDs here. Does this have a pointer? I don't know. Yeah. So one ID is this nice hexadecimal number that you can memorize. The other ID is actually, I don't want to say English, but easier to remember. So in my case, it was Sharp McNulty. It'll be different in your case because they make that up on the fly. You know, I mean, you know, they have 2 lists of obscure words, and they put them together with a hyphen or an underscore. There you go. Okay, are we up to the aha moment? Okay, and if you do Docker commit, then you commit the memorable name here, in my case, Sharp McNulty, to a new name, which in my example, I called Saturn. And now I have an image named Saturn, which consists of the Ubuntu plus all the software that I loaded. Okay. And I can treat that image, so I've defined 2 layers so far, right? I've defined the Ubuntu layer and the additional software layer. Okay. You type Docker images. I know. It's terrible getting old because you forget. I mean, I just did this stuff. But talk about parameters, talk about what are the actual commands, and if you don't do it instantaneously, forget. And so this will show Saturn, and this will show Ubuntu, and then the hello world if you've run the hello world. So Docker images will get you a list of images. Docker ps-a will get you a list of things that were containers that you could make images or may have made images. It gets a little more sophisticated. Yeah, question?
We're talking
Okay, yeah, so I have an image ID called Sharp McNulty. That's a name, it'll be different for you. That's the name that Docker made up for, I have a container. I contain, not an image name, a container name. That's a Docker made up name. And I don't want, I can't remember Docker made up names, so I will commit that and call it Saturn, and now I have a name that I can remember. And when I do an images, I don't see the Docker made up names. I only see the ones that I've committed. Okay. Okay, now we're going to run this little sucker. We built it, let's run it. So you execute run-i-t, and that's again a lowercase, well, it's, yeah. I renamed, for me it was a lowercase s. And now you're back inside the container. So you're running this container. And we want to load some more software. Okay, so I wrote a JavaScript and a little initialization program that I stuck out on GitHub. I put them on GitHub? Yeah, I put them on GitHub. And so now you want to download those. And so we're loading more software into the container. Oh, I'm sorry. You're absolutely right. Yeah. So don't do what I do. What I do. Do what I say. Yeah. Exactly. So one of the things I try and emphasize in my course. So there's a catchphrase in DevOps, which is sort of, if you do it once, that's okay. If you do the same thing twice, you should have automated it. And so in order to automate it, you have to know what it is. And so in order to know what it is, you need a list of process instructions. So I'm fairly rigorous when I grade these things. The students have to hand in a list of process instructions, step 1, step 2, step 3, and they should be understandable by someone other than the person that wrote them. And so I never would have let that go. Actually, my grader never would have let that go. Well, no, you don't fail, but you don't get full points. Yeah.
So Docker saves any changes made to the images every time I run it?
Docker gives you the opportunity to save any changes you made to the image every time you run it. Right. It's still there. So the question is it there just as an image, or is it there as a container running in the background? The answer is I don't know the answer to that question.
When you terminate, you get back to whatever you had in the image. There's nothing that's retained. That's the question. Right? It doesn't commit as you go unless you commit explicitly. So
yeah, but
I process the image, whatever. You can go back to the image original state. Right?
I terminated by doing a Control D. So the question is the question is that a terminate or just a movement back to the? Okay. So the answer is when I do a Control D, I'm not terminating the container, I'm just exiting the container. And so it does save it, and it's still running there. And now I can commit it.
But if I run it several times, in the PS-8, I get the different.
If you run it, you're running a different container of that same image. But if you attach to the image that to the container that it's already run.
So you can run an image more than once. You can't run a container more than once. So I could have, and actually the students do, and you could offline. we're gonna build a container that does a certain function. You can run that twice. I mean, we're gonna build an image that has a certain function built into it. And you can run it twice, get two different containers, and their output will be slightly different because of the program that you're downloading. Okay, have we hit the aha moment yet? Aha, thank you. Okay, so now we exit the container again. Yeah, I'm sorry, another question.
The wget container,
Yeah,
is that supposed to be on the?
that was part of the software that you downloaded. So apt-get install wget. And you can do that now if you want. I mean, you haven't lost anything. Yeah, question over here or comment?
This is what we have. So you say, what the issue is coming down.
It goes against the image. It's Docker run. It goes against the image that you specify there. So in this case, I'm running the image that I named Saturn. And all that run does is put you inside the container. What we'll see in a minute is you can run and execute something as a startup thing. But right now, all that run does is put you inside the container. This is not making sense to you. So we have images, which are just collections of bits. We have executing images, which are going to be containers. So once they're executing, they're a container. And it's kind of like the difference between a source version of a program and the executing version of a program. Or the executable file, yeah, and the execution of that executable file. That's a better analogy. Okay. So now we've loaded this. We do a Control D. We do PSA again. Get a list of containers. I have a new one here. Oh, here it is. Reverend Lewin. Yeah, I was looking for the name. Then I give Reverend Lewin a name. So I commit Reverend Lewin, which was the last one that I have, and I give it a name IP show. And the name is evocative, right? We're going to show IPs. That's what it does. Okay. Sure.
I wanted to see other operating systems are built like repository. Is there
So the repository, so the answer is I'm sure there is. I don't know what it is. There is a way of browsing the repository to find out what's available.
It's called Google Docker showing using repository.
Yeah. Okay. So we commit this, we give it a name. We ask for images again. We have the new image that we just created. Okay. Now we're going to run it. And now we have a whole bunch more parameters. Don't particularly worry about what they are, except that off at the end it says IP show /bin/bash. So the 8080, well, I don't know if you need to do it or not. Yeah. So if you're using VirtualBox, you need to do that. If you're not using VirtualBox, I don't know. I mean, so one of those ports is the incoming port. The other one is the one that goes to the application. In this case, it says transfer port 80 or port 8080 to port 8080. Okay, and what you should see, now go into your browser and type localhost 8080. So that's again a port name. And what you should see are 3 IP addresses. Okay, so you see the IP address of your machine, whatever it may be, on the Hilton network. You'll see 127.0.0.1, which is conventional. That's just a convention. That means your local host. And you'll see the IP address of the container. So what I have the students do at this point is run a second version and notice that the IP address of the container are different, that the 2 containers that they're creating are different. I'm not going to have you do that. Okay? So the purpose of this whole exercise, well, I mean, there were a number of purposes of the exercise, but the purpose of the particular exercise was to convince you that each container gets its own IP address. And that's an important element of the container because you can send messages to IP addresses. If it didn't have its own IP address, you couldn't send a message to it directly. You'd have to go through some other mechanism. So do we have an aha?
It's not on the list of options. It's not marked as executable on the .ts. You can't really run it. Now it gives you permission to run it. It still has root privileges on Linux and Ubuntu. So when we get that script, this script, on the native Mac, it comes back as just a file. It's not executable, so you can't run it. You got to change mode for it.
Oh, you have to change the permissions.
And then I have to change permissions, but now I get permission to that. There's other things, and it's not in the big bash. It's just you just get into the system.
Okay.
So certain of the paths are a little different.
Okay.
But I know this is going to do. I probably didn't ask, but I do need to change the permissions now.
Okay. So did anybody get it to work the way it was supposed to? Nope. 1. Yay! Okay, so you have to horse around a little bit to actually get it to show you to execute. And this is what I mean about them changing the versions on you. So Docker went from using VirtualBox, which is what these exercises, to being native. All of a sudden the instructions would change, and so you have to spend time. And again, the same answer that John gave for list of images is somebody has run into this problem. Somebody has reported it on Stack Overflow or some other kind of thing. If you just Google your error message that you get together with Docker or something, typically you'll find a description of the error and how to fix it. Okay, so let's pretend that everybody got it. So this is what you saw. You got IP addresses. Okay, so what have we seen? We hopefully at this point you understand the distinction between an image and a container. You understand creating an image in layers. And you understand how to provision a container or an image. You provision a container and turn it into an image. Yeah.
But layers, they don't create any kind of logical. I can't build them on. I can keep piling them on by knitting my image with more software installed on it, which gives me a better, more complete snapshot. But I can't take a container and then take a layer off. I cannot undo those 4 apt-gets we did.
That's correct, but you could start with Ubuntu and have another sequence. And I think this is the next slide. Okay, so these are just the topics I'm going to touch on. One of the things you can do is script it. So there's something called a Docker file, which is, run this. So you would take your Docker file, you would remove the things that did the apt-gets, and you would give it a different name when it came back. And then you'd have that process. You'd have two files, one of which went through the original process, one of went through your process with the layer removed.
And with the Docker file, again, the same thing. Run it, it'll create a container, run all the commands, then it'll commit to have a ready-to-go image,
Right.
which I can use later. The Docker file keep the records. If I need to redo the container again.
You version control everything. Well, you version control the Docker file in this case. Yeah, not the containers and the contents of the container, but so what you have is a record of it, and typically, you know, I will do a Docker file and it'll half work, and so then I do it, you know, then I'll just destroy the virtual machine and start over and run the doc fix whatever the latest error is, and then do it again, and so you can build it up incrementally in a fairly natural way. What happens when you get into scripting is it's another language to learn. So you have the Docker file scripting language, which is, you know, if you're just going to do straightforward things, it's straightforward. If you're going to start to do more sophisticated things, it's complicated. Okay. But the key thing is there is the concept of a scripting file. You don't have to do all this by hand. Okay, let's suppose you want to share the image. So rather than you doing everything, you're in a team. So one team is going to, you know, work on part of it. Another team's going to build up a different branch. So we'll use your your layer and not layer. So one member of the team's doing one thing, another member of the team is going off in a different direction. There's something called Docker Hub, which is a repository. And if I go back to that original oops, there it went. Over in the upper right-hand corner, it shows the Docker Hub. So all Docker Hub is a repository of the Docker images. And so you can create an account on Docker Hub. You can put things into Docker Hub. Anybody can take things. Anybody on your team can take things out once they have the credentials, and so on. Yeah.
Sorry, the images like stored as actual files, like, you know, so you could use Docker Hub, but use another version control. Let's say Git, can I push my images? Are they stored as a .docker image or something that I can control some other way?
I've never gone inside the hub to look at how they're stored. My guess is they're just stored as a collection of bits with no extension, but I don't know that. So it's just a guess. But you can pull the image to any host. So the next exercise I have the students do, so the students make this work, do it twice so they see two different IP addresses twice simultaneously, store the image in a Docker Hub, and then retrieve that image into Amazon EC2 from Docker Hub. And then run it, so then they get the Amazon images. And they use the Amazon container service, which has other features, which I'll talk about. You had a hand up here a minute ago or not? No. No question? Yeah.
So we downloaded Ubuntu to our container, right?
To the image.
Yeah. But that runs on different operating systems. What moment do we tell it it's going to run a Mac or Windows or whatever? Because it depends on the operating system, as I understand.
So the Mac OS and Windows have these hypervisor features. And they give you what looks to be a bare machine, which you then are loading Ubuntu into. And so you're telling it that it's running on, you're telling it that it's Ubuntu when you pull the Ubuntu image. So all of a sudden, Mac OS and Windows have turned themselves into hypervisors as opposed to native operating systems. And so it looks just like a hypervisor from that sense, in that it will run distinct virtual machines, except in this case, well, at that level, they are distinct virtual machines.
So running a VM would be heavier because it would load what else?
So running a VM is heavier for two reasons. the initial load of a container is going to take you as long as the initial load of a virtual machine, because I have to load the whole software stack. Subsequent loads, I just load the layer that's changed.
Because it's already running.
Because it's already there. Not necessarily running, but already there.
But your container should not, this doesn't really include your OS, right? That's going to be in terms of your VM. So you can't get away from having to load a VM, but once you have your VM loaded, in terms of loading containers, it should be much.
So what we'll see in a minute is that people like Amazon have pools of preloaded, half preloaded containers. And so it's much, you put some more muches in there quicker.
So there's two things. One is this ability to preload part of the container, the common part, and then just put your customization on top of that. The other is if I've got multiple applications, rather than having application, VM, each application in a VM, I could put multiple applications in a container.
So we, yes. So you're loading software into the container. There's nothing that stops you from loading independent applications, and they would then share what's below them. You have to worry about how they get invoked, but the invocation. But essentially, you can put as many applications as you want. So as many as you want sounds excessive. As many as will fit. Yeah. Of course.
Applications in your container, because fewer the applications, quicker you can load and scale that particular container and service.
Right.
Yes. Yeah. The smaller the container, the faster it is to deal with it.
Yeah. That's something.
Do we need to run an operating system in the container, or can we run the application directly using the host operating system as like a sandbox?
My guess is the latter, but I've never done that. So the question is, can we run, if we're running on OS 10, for example, can I load an application that runs directly on OS 10? Do I need to have an operating system layer in there?
The Docker for Windows thing, you can use either Linux-based or Windows-based. You can switch it, the engine itself.
At the engine level.
You can do one or the other.
Okay, so the answer is yes.
That should be faster.
But on the container, you still have to do the container image that you load. I still did the Ubuntu thing and ran that.
Yeah.
Yeah, typically your container is going to be multi-platform, where you might experience limitations on different platforms just in terms of the management software that you're using to scale with.
So the containers are trotting the Java path. It used to be, one of the things in Java was, write once, run anywhere. Didn't quite work. Same thing is true with containers. They're mobile, where mobile is in quotes, in that sense across platforms. So somewhat mobile. Okay, so we have scripting. We have Docker Hub. What about scaling? So what you've done so far is one container. Requests come into that container. Maybe you got too many requests. So how do you get more? So there's something called Docker Swarm. So Docker has a solution and AWS has a solution. What I'm going through here is Docker's solution. So Docker has something called a swarm. And what it says is treat these guys on the bottom, treat the hosts as one machine, and distribute the requests. So you run an image, and the request will be sent to one of the machines. And you run another image, and the request will be sent to a different machine. And typically does a round robin, although you probably have some control over that. Okay, so that's a way of manually scaling. You have to know how many hosts you have, and then you collect those hosts into a logical unit called a swarm, which is a collection of hosts that sort of share. in a sense, you could think, I don't know if this is going to be helpful or not. You could think of it as multiple cores. I don't know if that's a stretch. That's a stretch too far, probably. Don't think of it as multiple cores. Okay, well, in order to manage this, there's something called a swarm master. So you don't actually send the request to the swarm, you send the request to the swarm master. And you can have multiple swarm masters for different swarms, for different applications. And now there's a token that says which one do I want to deal with, which application. So there are different swarm masters, and each one will give you a token, and that token will identify which application you want to run.
So is that swarm master typically a specific process?
That swarm master typically is a separate container.
But it's a specific process itself. There's a single instance of that swarm master process.
For each swarm master that you have.
Yeah. So I mean, if this is a updating, that's kind of a single point of failure.
So it's overstating it in a couple ways. So this ends up getting way too complicated. And so, you know, so this just says in words what I just said, right? So a container gets to a host by either copying them or preloading them. Okay, so you can have multiple swarms. Scaling swarms means that you have to put the swarms underneath the control of an autoscaler. So now all of a sudden, Docker doesn't have built-in autoscalers. So in order to scale swarms, you would have to move to something like AWS that has autoscaling. Okay, and now we're starting to get way too complicated, and AWS has their own container management solution. So you just forget all I just said about swarms. Okay. So swarms are okay in a way, as a way of enabling you to build more processing capability, but the EC2, the AWS container management system, gives you auto-scaling, gives you all the features you would have with Swarm. It's just you're committing to AWS. That's all. So if you don't want to commit to AWS, you can build your own solution with swarms and so on. And it's kind of what you'd expect, right? I mean, you send a message to a load balancer. That's another thing the students didn't know. You send your message to a load balancer, the load balancer distributes it. You can separate it across regions for reliability, and so on. So the EC2 container management system is a lot easier to deal with than going down the swarm route. And there are other talks on Docker, and so you might ask, about the pluses and minuses of Swarm versus EC2 to some of these other talks. Okay, and there's also, so now we get back to your point, there's also something called Lambda. So let me have, as a cloud provider, as an AWS, let me keep a pool of partially filled containers with standard software platforms. So if I want to run Java, I have a bunch of machines with containers that contain the Java virtual machine. Now what happens is the load for a request is in microseconds, not milliseconds. So it is really, really fast. The only constraint is you only get one request per instance. So I have a service, I send a request to it, AWS spins up a new container, a Lambda request satisfies it and destroys it because it's fast to speed them up, to spin them up. I really mean microseconds.
They keep them around, or it's not deterministic. You can't know what organizations they do, but they'll keep them around for a little bit. They're not going to put them down in and out because that's not efficient. You're right, it's still very fast.
Yeah, so, and the charging scheme is different, so it's really much cheaper to, at this point.
But yeah, they don't charge you for when they keep them up
Right.
to serve you better, which they will do, but they'll be having to pay for it.
Yeah.
But they'll turn them down as soon as you don't use them. I use them.
Yeah. So yeah,
But when you say request, what does that mean?
that means a message coming into the application. From the, you send a message from so the term client now is getting overloaded. From outside the system into the system. So you have a web browser, and it sends a message to your application.
Lambda has a notion of triggers. So you subscribe your functions to a trigger. It can be a web service call. It can be an Amazon Alexa skill. And then Amazon will charge for the time your function ran. But I'm going to charge it for the time that it kept the container hot for the next execution if it decided to do so, right? It gives you certain guarantees how fast it's going to respond, but it will do smart things and keep them up, not, put them down. But you don't know how much. It's not something you can control. But they only charge you for the time your function actually ran.
And the other aspect of this is because you're going to get a different container with every request, you have to write your containers to be stateless. So there's some strong architectural implications of using something like Lambda, which isn't the case with the other containers necessarily.
So how do they clear that state?
What state?
Between of that kind of warm-started template, if you will, between runs. So I'm running something, I didn't do it well, right? I put some state into the application. Someone else then goes and uses that same container. Do they have access to that state?
Okay, so that's a general problem with virtual machines in general. So if I use a virtual machine and discard it, I may have left information there. Same thing is true here.
Is it information about lambdas or about containers?
So it's about Lambda.
It's about Lambda because, right, so according to the premise that it's essentially starting up so quickly because it's using a template pattern to keep those like certain instances ready to go, that implies to me that those instances exist.
But not the application.
I don't believe, it's going to be like my opinion from what I've used. I haven't tried putting any global state into my Alexa skill functions, so I did not get into, hey, I've got into some shared state that I've used before. I haven't tried reproducing the problem you're suggesting exists.
Yeah, I'm just
But
curious.
I don't believe there's a guarantee that they're going to wipe it away. If you leave something around lingering, and then the next function call may get stumbled upon it, then it's your design. Don't make those mistakes.
Yeah, but the other aspect of that, is that it's per application. So one application doesn't access the same container as another. It just accesses the lower layers. So you have to have put state into the lower layers. And something like Node.js doesn't retain state. Java Virtual Machine might, but the other kinds of applications, the lower layers don't retain state.
So does it enforce basically the inability, such as like, let's say, Atomic OS or something like that, the ability to save that state in that instance?
I doubt if there's any enforcement. Other questions? This is good. You guys know more than I do. It's supposed to be interactive. Linda's over there. Okay, so containers, they're lightweight. They give you isolation of the type that I talked about. Docker per se allows you to build images in layers and to retain those images. And so you can build up the system in layers. You can script it, so you do it with Docker file. And you can manage them either on top of virtual machines, or you can manage them using pre-allocated types of mechanisms. And there's an image repository, which is necessary if you're going to share these things. So more questions, more comments? All right, we have half an hour. We can solve these permission denied issues. So,
well, yeah, we can do that. My mistake was I was at mod plus X and then exiting the container and trying to run it, running to the old container. I realized after 5 minutes, man, I have to commit it with the change, then run that one, and then it worked. It worked. That made difference.
It did work. Okay, yes. Okay, other questions?
Yeah.
Yeah. Yeah. Okay, I think we're done.